6.3. Woo! I have so many little post-its that I have to do it like this. So we're adding and subtracting radicals. One thing when you're adding and subtracting, you have to have the exact same thing inside the radical. So this is just like the same thing as like if it was an x. You also have to make sure that you have the same index. If neither of those two things are true, you can't do it. So just like if this is the exact same index and same thing inside the radical, then you can take the coefficient out in front of that and add them together, or the coefficient out in front and subtract them. So looking at this one, I look first inside my radical so that they got exact same thing. Then I look at my index, they're the same. So I can take 3, because there are 3 of those right here, and then a minus 2. So 3 minus 2 would just give me 1. You don't technically have to have the 1 there, but you can if you so wish to. So that's my answer right there, simplified. Here, looking at this, so first I would want to look at my root. Those are not the same, so I cannot combine them. Even if they were the same, my x's aren't the same, so you have to be careful of both things. So this is completely factored. I can't simplify that any further, so this is all I can do. Looking at my next one. So looking inside my roots, 7xy, 7xy, that's good. Now I look at my index. Here's an index 3, here's an index 5. I cannot combine those. So again, this would be as simplified as I could go for that one. So adding and subtracting. So right off the bat, it kind of looks like I can't do anything. However, you have to simplify each one of these. Each one of these terms, remember the terms are in between addition and subtraction. So I'm going to have 6 times 2. Here I'm going to have a 3 times 2. Here is a pair of 2's. So the square root of 12 is the same thing as 2 square root 3. I have to do that for each one. 75 is the same thing as 3 times 25. And then we have 5 times 5. Oh, so here's my pair of 5's. It's still adding. So the 5 comes out, and this 3 is left inside. So square root 3. And then subtraction. A lot of people forget this right there. I'm going to put a 1 right there just because some people forget. Now, each one of these, I have the square root 3. So each one of these I can combine. So it would be like 2 plus 5, because those are the same. 2 plus 5 would give me 7. And then subtract 1. So my overall answer would be a 6. 2 plus 5, 7. Subtract 1 is 6. And they all have just 1 square root 3 in common. So right now I want you to pause the video and try to do the other one by yourself. Try to do B by yourself. Pause, unpause. So one thing that I first noticed is that this is a cubic root. Cubic root, you're looking for pairs or groups of 3. So factor tree, here's a group of 3. So just the 5 comes out and left with a cubic root of 2. Right here, when I look at my factor tree, here's a group of 3. The 3 comes out and left with just a cubic root of 2. Here's a group of 2, or here's a group of 3, which is 2. So that 2 comes out, this 2 is left inside. You have to make sure you have that index 3, that little index 3. I've had people get points. This is the only thing that they have gotten wrong on a test because they forget that itty bitty little index. You need that. So 5 plus 3 would give me 8. 8. Take away 2 would give me 6. Again, I can do that because all 3 indexes are the same and the radical inside is all the same. So it's 6 cubic root of 2. Next page. Whew. We have multiplying. So when I'm multiplying, it's still going to be the first, outside, inside, last. But now you're multiplying with roots. So my first here would give me 20. My outside, I can still multiply this 4 times this 4. So that would give me plus 16. And then I still have a square root 2. I couldn't multiply anything with a square root 2. My inside, so this 2 times 5 would give me a 10. And then I still have that square root 2 there. And now my last. So looking at my last, both of these two numbers are on the outside of the root. So 2 times 4 would give me 8. And then I would have to multiply my 2 radicals together because both of these radicals get multiplied together. So the same get multiplied. So square root 2 times square root 2 is the square root of 4. I can combine both of those. Those both have square root 2. They're the exact same root, same index. So I have 20. 16 plus 10 would give me 26, square root 2. And then I can rewrite the square root of 4. So this would be like 8 times 2. Now I can simplify this. 8 times 2 is 16, so this would be like a plus 16 instead. So now I can combine these two together. 20 plus 16 would give me a 36. And I still have my root, or 26 square root 2. Now when you're writing this, you should have your whole number first, and then if you have any radical or root numbers. So that is my final answer. Pause the video and try B by yourself. First, outside, inside, last. So 15, 3 square root 7, subtract 5 square root 7, minus 49. I replace the square root 49 with just 7 here. This 3 minus 5 is a negative 2. And then once this becomes negative 7, 15 minus 7 is 8. And I still have that subtract 2 square root 7. Conjugates. So what makes a conjugate? Conjugates, we did go over in chapter 4. So meaning it's both of them are binomials, and it's just the same two terms except different sign in the middle. So when I do this, first, so 5 times 5 is 25. Outside, 5 times square root 7 is 5 square root 7. Inside, negative square root 7 times 5 is a negative 5 square root 7. And last, negative square root 7 times positive square root 7 would be a negative square root 49. When you multiply by the conjugate, these middle two terms, when you combine them together, should cancel out. So there's no more square root 7 left. So now I have 25 minus the square root of 49 is 7. And 25 minus 7 would give me 18. So whenever you multiply by a conjugate and there's no variables here, you should end up with just a whole number, always. So you should try B by yourself. Pause, do B. First, outside, inside, last. Again, my two middle terms cancel. This becomes a minus square root 144, which is 12. 36, take away 12 is 24. So why would we have to go over conjugate first? It's because when we have to rationalize the denominator. So in the last chapter, we went over rationalize the denominator when there's only multiplying. Whenever you have adding subtraction now, you have to deal with conjugates. If there's adding subtraction in the denominator, you have to multiply by the conjugate. So my conjugate here is always looking at the bottom. My conjugate here, same two numbers. This says subtraction, this should be adding. Whatever is on bottom should be the exact same thing on top. So on top, I always draw my division bar personally. I multiply. So I can multiply my roots together, so this becomes 3 square root 10. Here becomes plus 3 square root 4. On bottom, square root 5 times square root 5 is the square root of 25. Square root 5 times square root 2 would be plus square root 10. Negative square root 2 times square root 5, negative square root 10. And negative square root 2 times square root 2 is negative square root 4. So my division bar, I can rewrite these now. This is 3 square root 10 plus 3 square root of 4 is 2. These two cancel, so this becomes square root of 25, 5. Square root of 4 is 2. So my answer here would be, I'm going to write this first. Your whole number should be first. So 6 plus 3 square root 10. So 6 plus 3 square root 10 over 3. So my actual overall answer should look like this. I'm going to have 6 over 3 plus 3 square root 10 over 3, which is equal to 2 plus square root 10. 2 plus square root 10. Because those can be simplified to 2, and that cancels out to just be square root 10. Try the next one by yourself. Oh, yep, that just happened. Okay, that's all right. Ripped the whole page. I was just so excited. My conjugate is 3 plus the square root of 6. So on top, I can multiply the 4x in, and I get this. On bottom, first, outside, inside, last, these two cancel. Square root 36 becomes just 6, and I subtract. And this is what I have. So I separate those two fractions. 12x divided by 3 gives me a 4x. 12 divided by 3 is 4. Here I can't simplify anything here. Do not simplify these. You cannot simplify a square root with a 3. And then there's my final answer. And that is all I have for you in this section. I hope you have a dandy of a day. Goodbye.